guessing this is pretty much where we left off last time, correct?
Yes, sir. Yeah.
So we'll continue the conversation from here, of course. And what other topics have been covered in this week?
Sir, we started. We're done with inductive effect. We have to do resonance now. Like we completed the first 5.
You started off with the effects basically. Inductive effect is completed, and
Yes, sir.
electromeric effect is also completed.
Yeah, hyperconjugation is also completed. Yeah.
Hyperconjugation is completed,
Yes, sir. Well,
but resonance is not done.
I mean, we're yet to do resonance. I mean, we started
The
masonry.
picture is a little weird, man. Seriously, this is not the first time I'm noticing this. This is not the ideal flow I would prefer any day. You'll understand when we are discussing hyperconjugation why I do not like this flow at all. So you do not understand what resonance is properly yet. Is that what I am supposed to assume? Or have you guys done resonance sometime long time back or something of that sort?
We've done resonance to an extent.
But you've not done resonance in organic, right? You have done resonance, if I remember correctly, from chemical bonding. The
Sir, we've
carbon.
done resonance in organic chemistry as well. Like, I mean, that's what we're doing right now. Like,
We've already done resonance in organic chemistry. Discuss
Yeah,
resonance first,
yes,
and
yes,
then
yes.
only went into hyperconjugation then.
Yeah, like pretty much. Like he taught simultaneously, kind of.
Then that's what I was confused about. When you said hyperconjugation was completed, but resonance was not completed, it didn't make sense. Usually they need to be discussed in synchronization, usually. Otherwise,
Yeah,
it
that's
won't
what we
make
did. Yeah.
perfect sense.
Yeah.
Then cool, my mistake then. I didn't get the full data as to what has happened. All right, so continue on. What else? Currently, you guys have covered hyperconjugation basics, and you are covering mesomeric effect in what to say? I'm assuming plus or minus R as of now. Is that correct?
R, no, we didn't do R.
Okay, all right, cool. And
So,
yes,
also, like a while back, you asked me why does resonance happen? Like, why does it tend to go to a lesser stable state and then come back?
so yeah, I did tell you, think, discuss, try to find an answer, and stop looking in chemistry, if I remember correctly.
Yeah, yes, sir. You're like, how come like waking up in the morning and stretching feels good, even though it's uncomfortable like that? Something along
Correct.
those
Yes,
lines.
it is.
Yeah.
It is. That is a very apt metaphor here. For instance, quartering used to be a punishment.
What?
Quartering means
No.
basically they hang you up like this by each extremity, and then they pull you
Oh.
up till you separate. Eventually, I think you get the terminology now as to
Yes.
where it
Yeah.
comes from. But
Yes, sir.
what to say? The idea there is, imagine if you're in that kind of a stretch position for like a few seconds. It feels fantastic, and then you come back. Right? That's when it feels fantastic. And just thinking about it makes me feel like stressing out. Stretch a little bit fully, and then come back. Now, so what is it that we gain? What is happening? Is that stretched position good for us? Is that a more stable state?
No, not more stable.
Right? It is an unstable state.
Yeah.
Correct. So, what is happening? What is happening here? That is an unstable state.
Yeah.
This is a more stable state. But
Yes.
going there and coming back makes this feel better. So, what's happened? In a sense, it's basically proving that the grass is not greener on the other side. Right?
Yeah.
In a sense, it is pretty much that only. But what exactly is happening here? You can look at everything from this point of view here. Now, everything which we have discussed over here is making sense logically, but it doesn't make sense mathematically.
Yeah.
So think mathematically, think physics now. What exactly is happening? We can't understand it in our state over here. That is a lot more complicated.
Hmm.
The metaphor here is for you to feel the effects of it, because it is pretty much a very apt metaphor to consider over here. But it is not the most ideal thing to look at it from the energy perspective there. So for the energy perspective, go to pure resonance chemistry there and try to explain it using physics. Because understand that this is pretty much exactly what's happened over there. Why is it that that is going to be superior? You're discussing aromaticity now, I presume. Is that correct?
Yes, sir. Yeah.
So now is the time when you should start exploring this question. So don't worry about it. The question is a little bit deep question. It is not something which is a small question. And when you're really looking at it from a physics perspective for the answer will be deep as well. And it won't connect one piece or two pieces. It will connect everything basically. It's physics. Physics will not be just one thing. Physics will talk about effectively discussing. It will give you a different angle of looking at electronic effects completely. So let your electronic effects finish. By that time, if you have an answer for me, we will see. Because what I'm trying to tell you here is the explanation for this logic over here will connect not just resonance alone, it will connect every possibility, meaning it will connect your hyperconjugation, it will connect your aromaticity, everything will get connected together. Because if the understanding is crystal, it's as simple as that. Things basically like everything connects. So now you have to look for a physics explanation of resonance. The question is the same. The question remains the same. I just want you to look at a physics explanation. And I will give you one extra hint here at this stage here. The ideal way to consider it is as a pair of electrons. I want you to consider why is it that a pair of electrons, which is capable of showing many different resonating structures, where obviously one of them is going to be the most stable, but the remaining are all less stable, but it is gaining stability through moving into the other structures. What is it that the pair of electrons is gaining more clinically? And what is happening here? And I would like you to consider that pair of electrons a little bit more closely. Try to understand what a pair means. Consider that question first, then try to consider the remaining things. Ultimately, it's all about what to say. If you break down the question to a lower by a lower by a lower by lower level and start questioning the assumptions. Ultimately, what are we questioning here? What am I asking you to question now? I'm asking you to question the assumption which you're able to feel in your bones, literally. And I'm asking you to question that assumption at the lowest level possible, which is at a pair of electrons. Because ultimately, what are we made up of? We are made up of a bunch of those pairs of electrons acting in synergy in some way. Right. So effectively, I want you to consider that question at a core level now. So start considering what are the pair of electrons? What does it mean to have a pair of electrons? That is where you should start from. Okay, now that is a question for later. Let's come back to things, this question after your entire aromaticity has been discussed and after you got a little bit more data. Okay, now let's go back to what else is left over in the current syllabus here. So we have this and put down in order, so to say. I want to start ticking them off as I'm going through. So I'm having cyclohexane, and I'll be having cistrons in this. What else do I have?
Silicon formula. Stability of conformer.
Be a bit more specific, na?
Stability of conformer.
Okay. All right. And what else? Next. See, the stability of conformers will come into the picture now in cyclohexane and cistrons also. So we'll start with somewhere over there itself. Uh, any other pieces?
That's about it.
No. It will not be rude of me not to ask this question. Have you got your 100 to 150 questions done in this current week?
No, sir, not yet.
And when are you planning on getting them? What is your count at right now?
So I'm at like somewhere around 50.
What is your count at now? 50.
Somewhere around there.
And when do you plan to finish this remaining 100 by?
This weekend, sir. I mean, I have a holiday tomorrow.
Oh, 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 okay. I understand now. I understand now. You understand this week by Saturday you should be at 300, right? You owe me 300. And I'm going to be as sincere as Brad Pitt in Inglorious Bastards. I want my scalps. I'm not kidding. I'm being very honest. I'll harass you every time. I want a count on a class by class by class basis. I want it to see as like properly it has to go up.
Okay.
And I want you to meticulously maintain which questions you have worked on.
Okay. Yeah.
You understand?
Yes, sir. I'll do that.
Because this is necessary. This is necessary. There's no escape here. The kids who you see who have come up, they have done this before. That's why they are there already. Or they have not done it in this concentration or in this intensity, certainly, but they have done the quantity over the large amount of time. That's even better, actually. Right? It's like slow aging, reversible process is always more good for the brain.
Yeah.
This year, what you're going to be doing is you've done thermodynamics, no?
No, sir.
No, not yet. But they're starting organic. Fuckers, what the fuck are they doing?
So we have online classes tomorrow.
Sorry?
We have chemistry online classes because we are very behind in syllabus.
You're seriously useless fuckers. I mean, I don't understand what the fuck they're doing in your school there, really. This is like December. They're not even touching, you've not done equilibrium. Equilibrium is like done to some extent, I suppose, right?
Yeah, we finished equilibrium
How they
completely.
Thermo is not done.
No, sir.
Oh. So they are going to be starting online classes also.
Yeah. Tomorrow and day after we have.
When you say online classes, explain.
Like, I mean, we haven't had many online classes before. But like, I guess I'm not sure exactly. I mean, they just teach online.
One to many,
Zoom.
basically, I suppose, right? Normal online.
Yeah.
Then there's nothing much different. Then pretty much the same thing as what we are doing over here. But you guys are basically, the problem with your batches is that you guys are a COVID hit set of kids. But they will not give you guys the COVID hit privilege for long, dude. You're in 11th. The current 12th batch has been given extreme privilege. You can see that they have removed a bunch of syllabus in JE mains.
Yeah.
But you know what JE advanced did? They just showed the finger nicely and left it to the side there. You get settled anyway. There's no escape there. They have to. This particular relaxation is for the COVID kids. There's no other way to look at it. The relaxation will go. So, anyway, coming back to the chemistry bits here. What else is missing? What else is a piece which is shaky?
That's about it.
Have you tried questions in the topic so far?
Yes, sir. I have.
And where all are you finding it complicated to pick up?
So mainly this confirmations.
And what else? Confirmations, I know, is a big issue.
Yeah,
That is going to be inevitably there. Other than confirmations,
that's
okay. So let's
that's
start
mainly
off.
it.
What do you understand by stereoisomers first? What
Serious.
do you understand by
Well,
stereoisomers?
they're isomers in which are differing by like uh yeah difference in the spatial
Let's first
arrangement
start
of
off.
atoms.
Let's first start off with what are we comparing? You're comparing
The
two structures on paper.
yes, sir.
Do these two structures represent the same compound or different compounds?
Same compound. Oh, no, 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 different compound, but same molecular formula. Sorry. Yeah.
So, two different compounds.
Yeah,
What is same?
their
Same
molecular formula.
molecular formula. And what else? And what else? If they are stereoisomers,
Structural formula.
structural formula. So, same structure. What is different though?
Arrangement of atoms.
Be more specific.
Spatial
Different
arrangement.
spatial arrangements,
Yeah.
which are non-interchangeable. Why are these non-interchangeable? They are non-interchangeable mainly because there is an energy barrier. What do I mean by an energy barrier? A bond has to be broken.
Hmm.
It doesn't have to be a bond has to be broken. It has to be something similar to a bond being broken, right? That is the basic understanding behind what is happening over here. Is this chain clear in your brain now?
So, but then why would there be an energy barrier? Shouldn't both have same energy?
Sorry?
Shouldn't both the compounds have same energy?
Repeat as to what you understood from that chain there. Have a look at that chain again.
Yeah, you said that different
Okay.
spatial
So,
arrangements. So,
what did this mean here?
certain amount of energy must be required to
Explain again. Think. What does energy barrier mean?
like in order to cross that barrier, you would have to supply some certain amount of energy. Pretty much.
Basically, if I want one of these diastereomers or stereoisomers to become its other stereoisomer,
Ah.
I will have to actually break a bond from some place and re-stitch the bond.
Hmm.
Maybe from a different direction, but I need to
Okay,
re.
okay, okay. Understood. Okay, okay. Yeah, yeah.
You
Got it.
understand the point over
Yes,
there?
sir. Yeah, yeah.
So whether it is going to be a cistrons or whether it is if it is cistrons, I'm going to have to break either the ring wala situation. One of the bonds in the ring has to be broken and then restitched. Or I'll have to break the pi cloud alone and then restitch.
Okay. Yeah.
In the case of optical, what will happen? I'll have to actually break a sigma and then reattach it from the opposite direction.
Yes, sir. Yeah. Hmm.
You're understanding what I'm trying to explain here.
Yes, sir.
So there is always going to be an energy barrier.
Hmm.
Breaking the bond requires energy. Correct. So
Yeah.
there is
Yes.
always going to be an energy barrier preventing one structure from becoming the other.
Okay. Yeah.
Is this part properly clear now?
Yes, sir. Yes.
This is the micro level flow which is going to be applicable when it comes to what is to be understood by stereoisomers. Now,
Hmm.
to understand stereoisomers most effectively, you need to understand spatial arrangements in three-dimensional molecules.
Hmm.
All right. When it is up to 2 dimension, it is acceptable. Things are going to be reasonable. If I remember correctly, I had also discussed and confirmed that your teacher has already discussed that any ring
Yes.
which is going to be, what to say,
One
8
equally.
or higher, there he seems to have already talked
Huh.
about the ring wala planarity conditionalities and
Yes.
how
Yeah.
those things work out. I
Yeah.
remember testing it out using the double bond wala thing in the ring case last time.
Yeah.
So if
Hmm.
your teacher has given that 8, he would have discussed everything else related to the 8 there.
Yeah.
Yes.
Yes.
So you guys know that a 5-membered ring is going to be having one carbon out of plane.
Yes.
And in a 6-membered ring, you're going to be having two
Two.
carbons out of plane.
A half chair.
So you're going to be having two carbons out of plane effectively. In a 7-membered ring, more of them. 8-membered ring as well, more of them. So effectively, you're going to be having different shapes applicable.
Hmm.
Now, let's go to your 6-membered ring and start off with things there. Now, before we go into the 6-membered ring, let's quickly touch upon this conformation stability part here. Why do you feel lost over here? Give me examples of what made you feel lost there.
Sir, I sent you a question. Can you see that?
Yeah, I'll have a look. See, the problem is you're banking too much on your eyes. I hate to sound like one of those stupid little Jackie Chan wala shitty bastards who is trying to be as cryptic as they can be in their in the way they sound. But yeah, I am as cryptic as I need to be. This is unfortunately a very shittily written question. Organic chemistry, you're going to be having huge number of questions necessarily available. You're
Hmm.
going to find shitty errors in questions, very stupid errors in questions. You're going
Hmm.
to have to stop seeing with your eyes and start seeing a little bit more with your brain. You have to start guessing what could have been the question, what should have been the question, what is it that I'm not looking at correctly over here, and what to say, start guessing around. Now, I'm 100% sure your teacher has taught about intramolecular hydrogen bonding possibilities.
Yes. Yes. Here that it happens. Yeah.
Only stupid problem is you don't see the neighboring carbon here.
Hmm.
This is the goddamn problem. You see the thing now?
That's to be three.
No, there is a CH over there. It is not a CH2. So there is CH3, CHOH, CH2F. This is carbon 1, this is carbon 2, this is carbon 3. This is the structure.
Oh, but why should be like that?
Because that's what the question is.
But
Because
why
that's
can't
what
you
the
do
question
that?
is. Look at the question. Which conformer of the above carbon is compound is most
Oh,
across C2,
C.
C3?
Two, three. One more carbon should be there. Oh,
No, not one more carbon should be there.
then
This is C2 and C3. The answer is supposed to be gauche, right?
yeah, it's gauche. Yeah.
Yeah. So what the problem was what over here for you? It didn't make sense, right?
Sir, if the OH and F are closer, like fully eclipsed, shouldn't there be a strong hydrogen bond?
Oh, you actually had a doubt with respect to the stuff which you learned in your school itself. Ah, okay.
Huh.
You had a doubt with why the gauche is more stable then.
Yeah.
Okay, that is your real question there then.
Yes. Yeah.
Oh, that is fairly easily solved. Sorry, I thought your issue was basically that this question looked weird. And there was another mistake in the question here, so I jumped on the obvious mistake there. My mistake here, sorry.
I didn't notice that. Yeah.
So you didn't even notice that there was an obvious mistake.
No.
Okay. So you have already blinded yourself to this. Good enough, not bad. So you're already seeing with the sight. That much pain you have felt then. You've been humiliated badly than these 2, 3 weeks in chemistry. Interesting.
Yeah.
My solution is very serious. I was not kidding about your 150 questions in a week. You have to start getting there.
Okay. Yeah.
There is no escape. I'm not even kidding about it. You owe me 300 questions by the end of this 30th. You understand that, right? That is last week. I'm counting it as last week. Bhad mein jaake, I only started the class from Tuesday or Wednesday. I'm not going to count it from that point of view. Yeah, tera week hai wo. So you owe me 150 for that week. And this week starts tomorrow. Not tomorrow. You can count it from Monday or whatever. I don't have a problem. But you owe me by Saturday before your Sunday class next week. You owe me at least it has to be at 250. Let it not be at 300. It has to be at 250. You can have like 50 for that Sunday. Not a problem. But it has to be at least 200 to 20 plus minimum. I hope I'm very clear here. I don't care what questions you solve. I basically want the numbers basically. What did I tell you? This is grinding.
Yeah.
I really don't give a fuck what questions you solve. Find the easiest questions you can solve. I want numbers. If you find the most shittiest questions, bad choice. I'm not even kidding. That is the attitude you have to start showing now. First bunch, collect the data about what type of questions are asked. Because you do not have data on that yet. That is where you are lacking. Understanding, you'll catch up. But this kind of experiential data, there's no way you can catch up without grinding the bit out. So start grinding.